Now we will learn about the disaccharides. Disaccharide means two saccharide group will be there, right? Two units will be there. So the first example is maltose. This is also known as malt sugar, and it is made up of glucose plus glucose. Okay, glucose plus glucose. So what is the ring structure? We will understand all these things with the ring structure. So you have learned in the ring structure of glucose, that is with carbon number 1 and 5, the bond is glycosidic bond is formed. So we have drawn this glucose here, this glucose here, and the bond is formed between glucose and glucose, that is with 1 and 4. You see, same ring structure is there because this is also glucose, this is also glucose, but the bond will form between 1 and 4, the glycosidic bond. See, in glucose number 1, in carbon number 1, aldehyde group is present, right? And in glucose carbon number 4, you see OH is present, right? So in this group, in this glucose CHO, this the aldehyde group is present, it is not removed, but here the bond is between the aldehyde group and the hydroxyl group. So we can say this is 1,4 glycosidic bond. So the bond is formed between the aldehyde group from first carbon and the hydroxyl group from OH. But in this carbon, the aldehyde group is present in carbon number 1. In this glucose, the aldehyde group is present in carbon number 1. So one aldehyde group is present. That's why it will be a reducing sugar. And we know any structure that contain aldehyde or keto group, it will be the reducing sugar. Now sucrose. Sucrose is also known as the cane sugar. It is the two units are glucose and fructose. So we know the structure of glucose is this and the structure of fructose is this. The bond is formed between 2 and 5. You see, between 2 and 5. And with 2 carbon, 1 carbon is attached. With 5 carbon, the 6 is attached. And the bond between this glucose and fructose will be with 1 and 2 carbon number. So that's why we call 1,2 glycosidic bond. In carbon number 1, we know in glucose the aldehyde group is present. In carbon number 2, in fructose, you see the O group is present, the ketone group is present. So here will be, keto group is present, right? O. So it will remove. So the aldehyde, you see the functional group from glucose, it's also gone, and the carbon number 2, the keto is also gone. So it will be, and there is no other functional group is present. Aldehyde is also removed from glucose, keto is also removed from this fructose. So it will be a non-reducing sugar. Now the next example is galactose. The structure of glucose and galactose, the actual ring structure, here I have drawn like this, but with one carbon we know na aldehyde group is present there with 1 number carbon, but after with 1 number carbon and 5th number carbon will form the glycosidic bond by removing 1 water. So it will be the ring structure of galactose. The ring structure of galactose and glucose is almost same. Only one difference, in carbon number 4, OH is here, H is here, and in carbon number 4, H will be here, OH will be here. This is the structural difference, but all the other structure are same, you see. Okay. In carbon number 5, why I have written CH2OH? You see here, carbon number 5, H2, this H, CH2OH. So that's why I have written in carbon number 5 CH2OH. CH2OH. Here also same. So only difference between galactose and glucose is this. And fructose I have also drawn 1, and between 4 the bond will be formed. Okay, the structure. Now the galactose, lactose is there is also two units, glucose and galactose. The bond will form between 1 and 4 like this. So in 1 there is one one carboxylic group is present. In carbon number 4 OH group is present. It is same like maltose. Because galactose structure is almost same like glucose. Here is aldehyde group is present. Here also aldehyde group is present. Here also aldehyde group present. But in fructose the keto group is present. So here in carbon number first in glucose the aldehyde group is gone because the bond is between 1 and 4. But in galactose the one aldehyde group is there because the bond is formed between OH and CaOH of this glucose, right? So in galactose the the CHO group is present, the aldehyde group is present. That's why it will be a reducing sugar. Clear? These are all disaccharide. Now one example of trisaccharides is raffinose. Raffinose is glucose, fructose plus galactose. Okay, we found this type of sugar in sugar beet and coffee. Okay, this is one type of oligosaccharide because we know from 3 to 7 all are oligosaccharides, right? So this is one type of oligosaccharide, but the example of trisaccharide is raffinose. Okay.